Hello, Internet. This is Rob. I've been asked to take a look at La Rioja, Spain UFO UAP video and give my take on it. So this is it. And just wanted to say thanks to Verdad Oculta, the source of the video, and you guys make sure you check out their channel if you get a chance and see what else they've got regarding this particular footage. I'm gonna take just a moment and show that to you. They have over 500,000 subscribers, so clearly he's doing something good over there. So take a look at it when you get a chance, and give those guys some thanks for letting me have the original file to take a look at. Also, before we go too far, I just wanted to point out this is the drone we're talking about, so you guys have this info. I could talk about it a little bit more in depth, and I'll give the specs for you. The main thing to know here is that it is a 78 degree field of view, and it's nice that we have that. So this is a drone with a fixed lens. It's not interchangeable lens, and it has auto exposure and shoots at a variable frame rate. So those things are important, and we'll address those again. You'll see that it says it's got a 26 millimeter lens, but I just want to point out that that's the 35 millimeter equivalent lens. It's actually a much wider lens than that, a smaller millimeter, because it is such a small sensor. It's actually a little bit smaller than a ½ inch. So I've got a page here to just show you. There's what the equivalent 35 millimeter full frame would be, and then not the equivalent, but there's what a reference for 35 millimeter would be. And then here are some other sizes of sensors for these digital cameras and drones. And as you can see, we're down here at this tiny little guy, just under a ½ inch. So what happens is when you want to talk apples to apples as far as lenses go, what we do is we say, what would a lens be equivalent to on a full frame? And that way we know we're all talking about the same thing, because we have a good frame of reference for what a certain lens looks like on a full frame. So for instance, let's say we put a 25 millimeter lens on a full frame camera. Most photographers and videographers would know what field of view they would expect and what level of distortion they would expect from that type of lens. And so if we put a 25 millimeter on, say, a micro four thirds, as you can see, it has a smaller sensor, about half the size. So that's called a crop factor. So it's actually cropping away half of the frame. It can only see about half of that field of view that you would see on a 35. So you have to multiply it times 2 to figure out approximately what the lens would be equivalent to. So a 25 millimeter on a 35 would actually be a 50 millimeter on a micro four thirds, because it's got a 2 times crop factor. And then if we're going to do it the other way around, if we put a 25 on a micro four thirds, that would actually be equal to a 50 on the 35 millimeter. So that way we can make comparisons for you to see. I have, for instance, an APS-C Canon camera, and mine is a 1.6 multiplier. So that's how I determine what the equivalent would be when comparing camera to camera. So we've got a little a small sensor here, and that can give us a little bit of distortion. But in any case, good to know. And the other thing to note here is that we're shooting in, you may have noticed the boxed in size of the video. We're shooting in 720, 1280 by 720. And I think this is why. I believe we're using the live view so that the drone operator can remote control it by looking at the screen. And he flies for about a mile away, so I believe that's why he was using this. And as you can see, it only goes up to 720 if you're using that type of live view. So I think that's why we have a smaller video. All makes sense. I've looked at the metadata. I'm no metadata expert, but I do have the ability to look at it, and it seems okay. There could be something off, but it seems to match what I would expect, put it that way. So anyway, thanks again, Verdad Oculta, and let's look back at the video. All right, so I'm going to run through this real quick for you guys so that you can see what we're dealing with. And so great that we have this initial shot, because we have a real-world frame of reference right from the beginning. Look how quickly these guys get small. So that's that wide-angle lens really exaggerating the distance. Very quickly, they disappear into little specks. It seems like we're far, but I think I'm going to be able to show you that we're not really that far before we turn around. So here we go. We're gonna make a turn in just a second. And one more thing I'll just point out, that I boosted the color just a little bit, but I haven't otherwise touched the original video. Just wanted to show it to you as it was, so that you had this. And I am going to skip over some parts. I've searched through and looked for other things that I could reference, or maybe some other little things happening, and maybe I found something I might be able to show you. But I'm going to skip through so we get to the part that everyone's focusing on right now. So I'm speed it up. And so let me just pause it right about here and get you guys to look at the hillside, right about where these bushes are, these little bushes here, and watch to see if you see something coming from that direction, and leave off screen to the right. This is playing real time. There we go. And off screen. So that takes about 3 seconds. All right. And I'm going to come back to that. So I'm just going to speed it up again so we can just see how this footage plays out, see what else we have to work with. Also notice that we're in orchards, which is very important. It seems to be very overcast, which gives us almost no shadows, lessens the contrast. But we have orchards. We have kind of a cold day. You saw the guys wearing jackets. Got smoke puffing out of a chimney down here. And there's cars on the roadway in the distance there. You see that? So we have some good things that we can reference for as distance and speed and so on. I've even looked at this on Google Maps, and there's some good street view images. Now look, we got darker, so you can see the auto exposure is exposing for the sky. So that's what happened there. And we're just about to the end, and we'll see a little car zip along the highway here, and we're done. Okay, so now let's get back to the beginning, and I'm going to switch over to a view that has everything a little bit bigger so you can see it. And so just remember that we're scaled up a little bit. And let me jump into where these guys are, and I want to show you when we zoom out. Take a look at the flag up here in the upper left-hand corner, and I've got a zoomed-in view of that. There it is. That thing is really going. So, oops, sorry about that. Try that one more time. I looked up the weather, and the weather says that it's about 45 degrees, somewhere between 35 and 55 that day. And we had a 9-mile-per-hour wind, but we are in the canyon. So, we can get different types of winds, but those things are important. All these are environmental factors to consider when looking to see what we might be looking at. Okay, and then I just want to point out that you can easily see these guys are kind of chilly. It's a little bit cold that day. He's even got his hood on. So let's go ahead and jump to the part where we're most interested in, and see that flyby again. A little bit bigger. Here we go. And off screen. And I'm just going to scrub it back and forth. There it is. You guys can see it. It does look a lot like the video from Utah, but it does have some differences, and it may be really similar in some ways. And I'm going to use some of the analysis that I have done on this video to actually re-examine that video again. But I just want to show you this closer. So here we go. Here's a stabilized version, and just watch coming out of the mountain right up in here, and we'll track with it. There's the object, see? Zips off screen. And I got a slower version of that. So here we go, and I put a little marker in for you. And this is no color editing. So as you can see, it's pretty washed out. So it's really hard to see that. I mean, it basically looks like it just appears out of nowhere. And that's because we don't have enough resolution to pick it up. So it's actually beyond the range where it can be resolved. And that's important. I want to show you why that's important, because I'm going to show you what I think we're dealing with here. All right, so then the object comes, and it does look like it tracks along that curve of the background and makes a nice turn. All those things make sense. And then it zooms off screen. So I think I can bring that back for you. So there it is. Just before it zooms off screen. We're scaled up a little bit, but there it is. But there's one thing to notice here. The first thing is we definitely have motion blur, and it's definitely moving fast enough to cause some transparency. But if I stop it, let's go back to the real size version. In fact, you know what? I'm going to scale this up for you in this version so that we can see it and stop it right there where we have a dark background. And the issue I have is we're close to the lens, and it's easy for me to tell because we have a fuzzy edge, fuzzy edges. So bear with me for just a second. So when we have motion blur, we're going to get blur in the direction of travel. So this object is going from left to right. So we expect to see faded and translucent edges on the front and on the back. But the top and bottom sides should be relatively defined if they're in the focal range. And as you can see, it's not beautiful, but because the resolution is bad. But if you look at the rocks on the hillside, you can see we do have some focus. We do have some contrast. And I'll zoom back out so that it makes more sense. A long distance, we've got focus, but this thing is starting to get fuzzy. That's telling me it's close to the lens, and that's important. It's close to the lens. All right, we don't see wings flapping or anything, but this is supposed to be possibly a flying phenomenon of some sort that would warrant our interest. And so we're checking to see what that would be. My perception right now is this is something close to the lens. But we see it come from a distance and it seems to follow the background. So how is that? How is that possible? Well, first of all, let's address the close to the lens. How is it that I'm saying that? All right, so I did a little bit of a test for you guys, but I'm going to start with this picture. Not this picture. This picture. And so what I want you to notice is this is a picture that's taken, and we have focus because we're focused on the guy right in the center. So the camera's not moving, but the cars are moving, right? So let's treat this car as the object. When an object moves, it's moving from left to right, we assume. And you see, we get the faded front and the back. In fact, we can even see through the front. You can see the guy's pants leg through the front of the car there, right? You can see through the back of the car here. So the front and the back are moving significantly and changing for the camera. However, the center, top, and the bottom are not changing very much. So the camera is able to render for a longer period of time what's happening, right? Even on the car that's closer, we get still, the top is still relatively in focus, right? The other distant car, we get the same thing. The bottom is relatively sharp. You wouldn't even know it was moving if you only looked at that part. Same up top, right? And so what happens is when something is in the focal range, but there's motion blur, we can tell that it's motion blur and that it's still in the focal range, as long as it's a solid object that's moving. Of course, if it's got fuzzy edges already because it's flapping around with wings or something like that, then we're going to see that type of distortion. But the presumption is that we may have some sort of unknown object, and if that's the case, we would expect to see sharper edges. So I know this doesn't seem like a real-world comparison, so I did something else. I used this little gadget here, and it has a ping pong ball on the end. It's a stick that is about 3 feet long. I'm not sure how long it is. And it's got a little white sphere on the end and then some wires holding them up. And what I did is I recorded a video for you guys to show you how we can get some lens distortion. All right, so look at that. If you position it correctly, you can get both of these objects to look the same size in the frame. And the cool thing is, if you move them in the right arc, you can get them to clear through the frame at the same apparent speed, even though one is closer than the other, which means the farther one is actually traveling faster. But they still go through the frame at the same time. So we can compare them. So I did a little slower, and I got one that's just a little bit slower here. There we go. And let's see if we can just freeze it somewhere. All right, that's a good spot. And now take a look, if you will, at the edges here. There's the ping pong ball, right? Look at its relatively sharp edges. Even though we have almost transparent, we can see through the edges. Translucent would be the right word, right? There we go. On the top one, same motion blur. But look at this. Look at the blur that we get because it's close to the lens. We can see through the edges. It doesn't have defined edges. So this is in the focal range, and this is outside of the focal range. And that tells me it's close to the lens. All right. I think you get it. That was my little test. Okay. So that is why I think this is something small and close to the lens, which, of course, leads to thinking that it's possibly a bug. So now the next question is, let's look at this thing in the real world. Okay, let's go to Spain, everybody. Let's go to La Rioja, Spain. Let's see if we can take a look at where this drone operator is. That should look familiar, that spot there. And let's just take a quick look, get our real world reference. So there we go. All right. So I think you guys are okay with that. Pretty neat. All right. So let's look at how far things are. All right. We have when the drone is closest to our drone operator, it's like literally right on top of them, and we can tell approximately where it is by looking at that field of view again. So I have actually an overlay that shows me the field of view, right? So it shows me what 78 degrees looks like, and then I can place that over the image. There's some tricks to, of course, pay attention to, but I feel like I've got it about in the right spot. You definitely want to place it based on the center of the frame on the left and the right, because when the drone camera tilts, you will get distortion. But in any case, you can be pretty accurate, and so that's what I've done. And so I think this thing starts out pretty close to them, and you know, if we just throw a measure in here, about 10 feet, so maybe it's 20 feet up in the air, something like that. All right, and then it flies away from them. So let's take a look where this thing starts when it's really close to them. Okay, here we go. There's our closest point right there, and it's right before we take off. And so I want to just say, first of all, look at their hands. We got some serious motion blur here. They're not even can't even see the fingers when they wave. So definitely got some motion blur happening. But also take a look at this guy's jacket. See, he's got a nice spot on the front of his jacket. Nice contrasty spot there that we can use as a reference. And so I want to say pay attention to that as we take off, and let's keep looking at that, and let's see, when can we not see that anymore, because we can see that pretty well. As we back up, it starts to disappear, and I would say right about now it's so pixelated that we can't even tell that there was a separate mark there. It's almost hard to see his jacket, what's on his jacket altogether. And then if we keep going, it's really hard to even tell anything is on his jacket at this point. So, and this is zoomed in, by the way. So let me just correct that for you, and I think you'll see. It seems like we're really far away, but remember, it's the lens that's doing that because it's a wide-angle lens. So as we fly away, things degrade really quickly. So it goes from being something that's visible, only 20 feet away, to, and we're just guessing 20 feet away, right? Because it seems like we're over the fence. If you look, we're just about over the fence, to almost disappearing. And you think, well, we've gone a really great distance, but I can actually figure that out. We can look and see just how far have we gone. So we have their farthest distance here, which is, if we let this thing play through, you'll see we keep going and going. And it just seems like, wow, we've gone so far. It almost seems like, those guys are practically imperceivable right there on the hillside. That almost seems like a half a mile. But we can look on Google Earth, and I have that farthest point. And it's right about here. And I can tell that this is the right point because I have the field of view. And so this field of view shows me the left and the right extents. So, if you take a look, for instance, and keep in mind, we pay attention to what's approximately center of the frame. So like, look at this field. You see the edge of the field here? And then over on the right, we have the fields there. You can see there's a little white house of some kind there. So switch back to the video. And now we got the same thing. See, on the left-hand side, we've got the field, and over on the right, there's the house. So we're looking at this field of view in order to find where we are. You can see the field below us and the stream down there. So where are we at on Google Earth? Well, there's the field. And remember, our our frame cuts off at a certain point, so we're not going to see all the way below the drone. So we're able to triangulate which direction we're pointing, what things are in the frame, and figure out approximately where the drone is. So how far is that? It's pretty cool. Let's go here. So about 650 feet, right? So that's cool. 650 feet. Okay, so let's take a look now over at where the drone flyby happens. Okay, and so hopefully you guys agree this is about where we are. Let me show you that in the video, and it should be right about here. All right, so here's where our flyby happens, and there it is. Okay, so this is really interesting because it looks like the object is making the turn, compensating for the valley, and we can even see that valley here. If you turn it around and do the reverse view. Sorry about that. There's the reverse view, and it makes sense that it would fly by the bush here and then avoid the mountains and then fly off in the distance. Makes sense. All right, but what if, let's try to get back to our right spot here. There we go. All right, what if instead of this flight path, and I did the best that Google Earth will let me do here. I drew in a flight path. Now, flight path doesn't... it doesn't let me change the altitude, so everything has to be one consistent altitude. But you can see that we get the idea. So it's a flight path that takes the drone past the hillside, right? And it matches up against the hills, so we can see approximately where it would go, and it flies past the drone. It makes perfect sense. Makes perfect sense. So I'm not saying that it doesn't do that, but what I'm saying is, what if instead of that, it was this? What if it was this or something closer to this that we were seeing? And so now we still have a path that will match up to the background for the drone's camera, and we still have a path that comes past the drone, but actually it's not anywhere near the background. It's closer to the camera, right? Which could happen, and it doesn't have to go this far. Maybe it's even shorter. And this is important that it could be shorter, because let's take a look at the measurement here and see. Oh, by the way, let me just validate where we are again. So is the drone in the right spot for this measurement? Not jump too soon. So on our left side, you can see we've got the hills here, and it goes up to the peak. And on the right-hand side, we got the roads, right? The way they fall off into the distance, right? And so let's see what we have here. So we got the rocks, and then the peak over on the left, and then over on the right, you see we got the field. Actually, there's a little snippet of the road, and then the field. The way that's cut. Let's see. Is that matching up? Yeah. So there's the field, right? No, actually, right here I think is the one we're talking about. Like this, and this. So this is the road on the right hand side, and then the field, and switch back to the road, right? There it is, and then the field. So pretty cool. I think we just about got it. So it helps us get the right location for the drone. Right? It could be a little bit off, but it's pretty close. So the idea is, if we measure this, about what distance are we talking about? So I'm measuring to where it crosses the bush, and it looks like about 600 feet. So that's close to what we saw as the farthest point from when the drone took off, the farthest point from the people before it turns. So that's neat because we can use that to see how does this thing appear? How does it seem like it's coming out of nowhere? All right. So if it were a bug, right, you might remember before we've established that the fastest bug, and this is probably not the fastest, can go 35 miles per hour, right? So that's divide that by 60 is this is miles in minute, and then divide by 60 again, and this is miles in a second. Multiply that times feet, right? And so there's how many feet per second a bug can travel. 51 feet per second, right? So if this is lasting for 3 seconds, then this bug times 3 can go 154 feet, if we assume that this might be a bug. Because we have to test the real world, right? So we have to say, what could this be? So 154 feet is how far it could go in 3 seconds. Now, that means 154 feet away, it has to be disappearing out of view. It has to be so far away that we can't resolve a tiny bug in those pixels. So is that possible? Does this drone resolve bugs that far away? Or do they disappear? Because if that's the case, and then we have the fuzziness near the lens, it tends to really solidify this is very likely a bug. So is there a way we can test that? Well, I think there is. So if we go back over to the original location where we take off from, right? And then we say, well, what is this farthest distance, right? And let's see, let's look at the farthest distance. And bear with me here. All right. So the farthest distance is, so what have I got? About 650. Okay. So 650. All right. So how far between when it takes off and when it stops before it turns is 154 feet. So I did a little math, and I can do that again. 650 divided by 154 is about a quarter, right? So 4.22. So it's a quarter of the way. There. So what that means is if it travels at a relatively consistent speed from takeoff to the point where it stops, then if we just go a quarter of the way, then we should be at about the 154 foot mark, right? So that is, let's see, let's take a look again at where it takes off from, right? There's the closest spot. And the length of time that it goes for is 33 seconds. So 33 seconds. Let's do this again. 33 seconds divided by 4.22 equals 7.8. So about 8 seconds is what a quarter would be, right? So if we go for about 8 seconds. So if I look on my timeline and I go for about 8 seconds, let's see if we're in the right spot. And so here's our guys. Here's right before the drone starts to move, and here we go. Let's do this. Let me zoom in a little bit on my end. And let's go 1, 2, 3, 4, 5, 6, 7, 8. And so 8 would be actually right here. I counted wrong. So there's 8 seconds. Are you surprised? So that would be about 154 feet away. So let's see if we're right. So let's look along the sides. We've got to try and pick target areas to line up our field of view and see if we're about right. So we need kind of cutting off the pool and like where this gouge is on the side here, right? So let's take a look. And let's go to 154 feet from there we go. And see if we're in the right spot. So we've got a field of view right here, cutting off that side, snipping the pool and going down the hillside, puts us right about there. Let's see what that lines up to. All right. I'm going to go 175 feet. So that means we're actually, oops, sorry about that. That means we're actually farther. So 154 is about right there. So pretty close, actually. I'd say that's pretty close to being in the right spot. So even if we go a little bit closer with our camera, a little bit closer, I think you can agree with me that if we consider the spot on our drone operator's jacket to be a bug, that thing is not perceivable. I mean, I'm even going to zoom in. This is 300%. Or we're zoomed in 300%. So if he had a bug on his jacket, we could not see it. It's Still going. Yeah, only now are we starting to be able to see it. Yeah, so it starts to disappear pretty quick. So you just can't, the camera just can't resolve it. And let me just go back to, there we go. So that's not at 8 seconds right there, and we've just lost it. So watch this dot again, right here. And it's got pretty good contrast on that little dot there. See the line on his jacket? Or maybe you see something else you want to pick to use as a reference. But pretend it's a bug, and let's see. Let's go to 8 seconds. There's 8 seconds. Look, we can still see the hillside. We can't even see the ground yet. The way this lens is working, it makes things look farther away. So if there was a bug in the air between us and the drone operator, it would actually probably not render. And so it would look like it was coming into view from out of nowhere, which means that it could look like it was coming from really far away and suddenly just appear. It's an exaggeration of the lens. So that's what I think, guys. I think that's probably what we're seeing is I think we're seeing a bug that is actually making the turn in another spot closer. And it makes sense, actually. If you still look at the landscape, it still makes sense that a bug would be making this turn right here. And it wouldn't even have to be this far. Remember we said 154 feet. So, and that's not even counting the wind blowing. If the wind was blowing, it could be even farther away. So 154 feet is only that far right there, right? So the bug would only have to be this far away from the drone. So just flying in and making a little zip of a turn is all we would need in order for that to happen. In order for us to perceive it as if it were coming from far away against the background. I'm not saying that it's a bug. I'm not. I don't want to blow the interest in this video because of what my opinion is. I don't have a way to prove it, but I'm just showing you the things that I use to evaluate it because I'm interested in this. And so what I'm finding is that it looks like it's a bug that is coming from I should say the evidence that I am analyzing says that it's a bug that is coming from close to the lens. Here it is again. So I did one other thing. I stabilized it for you, but I also did something called an echo trace. And so I added an echo to the video, and then it copies the frames over top of themselves so we could see the path. And you can see each time the camera lens, I'm sure the shutter opens and closes, we get a new bug. And they just append on themselves. And you get some blurring because of the movement, of course. In fact, we're adding frames upon frames. But the neat thing it does is it shows you the path all stacked together, which is kind of cool. So if we look at that, and you look at this foreground cliff here, it is a little bit more easy to see how maybe this is something that's coming from closer. You know, maybe it's just coming in. We can't quite see it because it's just out of the focal distance. And then suddenly, zip, now we can see it, and it's back out again. It makes sense. It's a little easier to believe than something off in the distance. There are other environmental factors that it could be too. It might not be a bug. You know, we saw the smoke coming from the chimneys in the distance here. It could actually be it could be ash from the chimney that's being blown by that wind. You know, could it travel that fast? I don't know. It really depends. Remember how we said that it doesn't have to be coming from that far away. It only has to be coming from 154 feet if it's a bug. So what if it's a tiny piece of ash that's even smaller than a bug? Does it have to be that far away? I'm not sure that it does. So anyway, hopefully I haven't taken the wind out of your sails. This is still a really compelling video, and I certainly have not, I think, squashed it. I've only, to use a bug term, I just have given my opinion. But there is one more thing that's interesting, and I'd like to show it to you. So in this video, it plays through again, and the drone stops at another point. And I'm going to zip on to that. And I actually think this might be a tad more interesting than that particular flyby. And I'll show you why. Let's get there. So So remember we come to the little town here, and it's really neat to actually look at this little town in the Google Street View, because actually the Street View does go through the town, and it's pretty neat. But I noticed something. Let me let the drone reposition itself, and you can see this footage is just really tough. There's another object that flies through this scene. You notice we have seen almost nothing. There's no birds. There's no people. But now I'm zooming in here, so I'm sorry to confuse you there, but I just zoomed in, and I want you to watch coming right down the hillside here. There it is. And it almost is floating. Sorry, my computer doesn't like rendering this stabilization very well. There it is. It's almost floating. And it's going really slow along the hillside. Now, the interesting thing is that hillside is pretty far away. So it's easy to say, well, it almost looks like it's wobbling, the shape of it. That could be a flapping motion. Maybe it's a bird. And then all of a sudden, it drops into the trees out of view, right? So the cool thing is we know where that is, and it's right down here. And we can measure that, and we can see it comes into the hillside here, and it moves behind the trees here, which is about 150 feet. So if we say, we need how long? How long did it take to go this distance? So we can see how fast it's going. So I have to look at my my timeline to see just how long does it take for it to travel this distance. I have a time of, let's measure from the point where it's actually just after the turn there, right? Yeah, there it is. So just after the turn, right up until it drops behind the trees. So if I look at my time, I get 26 seconds. And you guys can verify that separately if you want to. So 26 seconds. So let's just look on here again. And we're dropping behind the tree. Maybe it goes these trees here. So from here to, oh, right, the trees are in the corner. So right there, I think, is the tree we're talking about. 160 feet. So how fast is this thing going? It goes 160 feet in 26 seconds. 26 seconds, right? So there's how many feet per second it goes, right? So times 60 is how many feet in a minute. And then times 60 again is feet per hour divided by the feet in a mile gives us miles per hour. That's 4 miles per hour, right? And depending on how you measure that, I don't think it even went that far. That's slower than a bird. The slowest bird I looked up can fly at 5 miles per hour. So this thing is just kind of leisurely putting along here, and it doesn't seem to be doing a lot of hovering or anything like that. It's relatively small because of the distance. It's hard to tell, but it still renders. And we just showed how something that's that far away doesn't render very well. So it could be a gliding bird maybe, or it could be a relatively large insect like a butterfly. And it is wintertime, but I was able to find that there is such a butterfly in this area. And the funny thing is, it says, oops, my bad, there. It says that the flight period for this butterfly is May to August, except in Spain, where it basically flies all year. So that's kind of interesting. It could be a butterfly, but I'm not sure, guys. I think it's pretty compelling. A pretty neat thing to be looking at. So I'm going to show you that again. And it does seem to have a yellow color. See that? So I might be looking at a butterfly. So whereabouts is the drone where it can see this? Those are pixels that you're seeing too. So it's really hard to tell if that's flapping or if that's going from pixel to pixel, because we're really zoomed in. And then it drops off. Yep, it's really hard to tell what happens there. So I have the path that takes, but I also have a trace of that as well. And here it comes. Excuse the a movement. There. So what you would be looking for are bright spots that would represent flapping of yellow wings going open and closed. And I do think we see some of that, but it's really inconclusive. There it is. So, all right. So there's what I've got for this video. I think the first object flyby is very hard to tell from a small object close to the lens. It does seem to be consistent with that. And I think the other object here has potential to be a butterfly, but it's also pretty cool. And I like finding these things. So, all right, folks. Well, I certainly appreciate all of your time, and I hope I haven't spoiled your interest in this subject matter. Just because something seems rather explainable doesn't mean that it is. And thank you for paying attention, and we'll catch you on the internet.